Hi, this is just a brief tutorial on how to solve some rational equations. We started in class learning two methods, and this first method that we're going to use is our proportional reasoning method. And that's why the directions say solve each rational equation using cross multiplication, and then also describe any restrictions for the values of x. So the first thing that I'm going to do is I'm going to list my restrictions. And again, we said our restrictions are values that will make you divide by 0. So in this problem, my restrictions are x can't be -3 and x can't be -1. So we just want to make sure that we list those first. And now we're going to solve, and it says use cross multiplication. So as I'm solving, again in cross multiplication, I have this upper one of x minus 1, and it's going to be multiplied by x plus 1. And then we cross multiply the other way, so my numerator on the right was x minus 2, and I'm going to multiply that times x plus 3. So we cross multiplied. Then the step that some of us just kind of needed to remember was we need to distribute. So I like to do x times x, which is x squared. Then I do x times the 1, so that's just plus x. Then I do -1 times x, so that's minus x. And -1 times 1, so that is a -1. Do the same thing on the other side. X times x is x squared. X times 3 is plus 3x. 2 times x, sorry, -2 times x is -2x. And -2 times 3 is -6. So we cross multiplied, then we distribute. Now I'm just going to combine like terms just on each side. So I actually get x squared, those two cancel out, -1 on the left. On the right I have an x squared, and I have a 3x and a -2x, so I get a plus x minus 6. So combine like terms with my next step. Now I'm going to solve for x, and I notice there's an x squared on both sides, so if I subtract them from both sides, I'm just left with -1 equals x minus 6. Now I'm going to add 6 to both sides. So if I add 6 to this side, I get 5, and I get x. So my final answer to this problem is x equals 5. And I know it's a solution because if I check, it is not one of the two restrictions that I listed. So that's just how we did our cross multiplication types of solving. We know that cross multiplication is a good method when there's only one factor in both the numerators and the denominators. So when we cross multiply, we're only getting quadratics. That's a good way to check it and to make sure. We also know it's a good method is because when we get to our combine like terms and simplifying steps, it's either a linear or a quadratic term, which is easy to solve. The next method that we're going to use is we're going to use our least common denominator method. And that's typically used when you don't just have one fraction equaling another. There's multiple fractions on a side, or you have multiple factors in a denominator. So the first thing we need to do is we need to list again our restrictions. So for this first fraction, our restriction x can't be 0 in our first fraction. Likewise, x can't be 0 in our second fraction, and x can't be 0 in our third. So our only restriction is x can't be 0 when we're all done with this. The next thing we need to do is we need to figure out our lowest common denominator. And one of the things we saw in our book was if you're not sure what the lowest common denominator is, make them all have common denominators. So for this first fraction, it already has an x, but it needs a 2, and it needs a second x. So I need to have a 2x squared. So in order to do that, I'm taking let me just kind of start over so that you can see what I'm multiplying by. So again, I had a 2 over x. It needs to have a 2 because this guy has a 2, and it needs to have a second x because this guy has 2 x's. So that means whatever I do to the bottom, I also have to multiply times the top. For my middle fraction, it already has a 2, it already has an x, it needs another x, so the top needs another x. And the fraction on the right already has an x squared, so it needs to be multiplied by 2 on both the top and the bottom. So if I kind of simplify my equation, I have a 4x over 2x squared. I have a 3x over 2x squared, and that equals a 2 over 2x squared. So if you're unsure of what the lowest common denominator is, make them all have a common denominator. So my lowest common denominator, or they say least common denominator, is 2x squared. Okay, so if it's 2x squared, our methods that we learned in class was multiply every piece of this entire equation, multiply it by that lowest common denominator. Multiply it by everything in here by that lowest common denominator. So what that means is my first fraction was 4x. And again, as we're multiplying by this least common denominator, remember it's over 1. So that means this will become 4x times 2x squared divided by 2x squared. This becomes 3x times 2x squared over 2x squared. And this becomes 2 times 2x squared over 2x squared. And so the reason we multiply by this lowest common denominator is because now we can go back through and we can cancel. This cancels out, this cancels out, this cancels out, and so we're just left with a linear, well, a 4x, so a linear term here, minus just a 3 equals 2. So we're just left with a small algebraic equation for us to now solve for x. And I just realized there was an x up here that I forgot to rewrite, which means in my final answer there's also an x here. So it always helps to go back and just double check, did you rewrite everything correctly? And I just realized I missed that x. Okay, so I just gave myself a little bit more room up here, and so this is the equation we just came up with. Obviously we can combine like terms because I remembered that I forgot the x. So 4x minus 3x is just x. So x equals 2 in this problem. We know it's a solution again because it does not match our restriction. And again, we should always go through and check it, but the big thing is because it doesn't match our restriction, we know that this is a solution. If you have any questions about solving, remember to first look at your chapter summary in your book. That does a great job of just giving you some examples of these two methods. Likewise, you can always email your math teacher, come in and see us during resource or after school. But please ask if you are confused or just want to clarify something. Thanks.